Chandrayaan 3, India's third lunar mission, represents a significant achievement as it successfully landed a spacecraft near the lunar south pole for the first time. With this historic feat, India joins the rank of the USA, Russia, and China as one of the few countries to achieve a soft landing on the moon. More notably, India has become the first nation to land in the close proximity to the lunar south pole, a location of immense interest for future lunar bases. The lunar south pole presents a unique and challenging environment, with temperatures ranging from -10 to 60 degrees Celsius, depending on the depth and the possibility of water ice trapped in permanently shadowed craters. Water ice is of paramount importance for the future lunar missions, as it can serve as a source of drinking water, oxygen, and rocket fuel. Chandrayaan 3's primary objectives include studying the lunar environment and resources in the South Pole region, as well as measuring the temperature profile and chemical composition of the lunar soil. Chandrayaan 3 is a pivotal component of India's ambitious space program, which traces its origin back to 1962, when India launched its first rocket from the fishing village of Tumba. Over the years, India has launched numerous satellites, rockets, and space probes, establishing itself as a prominent player in the space exploration. Chandrayaan 1, India's inaugural lunar mission in 2008, orbited the moon for nearly a year, providing valuable data and images of the lunar surface. Additionally, it carried the Moon Impact Probe, which intentionally crashed into the lunar south pole region and detected traces of water molecules in the lunar atmosphere. Chandrayaan 2, India's second lunar mission in 2019, comprised an orbiter, lander Vikram, and rover Pragyan. While the orbiter continues to orbit the moon with its high-resolution camera, the lander and the rover unfortunately lost contact with Earth during their final descent and crashed on the lunar surface. Undeterred by the setback, India embarked on Chandrayaan 3, which essentially replicates the lander and the rover of Chandrayaan 2, but with enhancements and modifications. On July 15, 2023, Chandrayaan 3 was launched from India's Satish Dhawan Space Center. It journeyed for about a month to reach the moon's orbit, where it performed crucial maneuvers to adjust its trajectory and altitude. On August 20, 2023, Chandrayaan 3 initiated its perilous descent towards the uncharted South Pole region, encountering several challenges along the way. Firstly, there existed a communication delay of approximately 3 seconds between Earth and the Moon, necessitating Chandrayaan 3 to autonomously navigate and control its speed and direction using onboard computers and sensors. Furthermore, the lack of detailed maps of the landing site meant that Chandrayaan 3 relied on its own cameras and radar to survey the terrain and avoid potential obstacles such as rocks and craters. Lastly, the South Pole region experiences minimal sunlight, compelling to rely on its batteries and solar panels to power its systems and instruments. Despite these formidable challenges, Chandrayaan 3 triumphantly achieved a successful landing near the South Pole on August 20, 2023, marking a historic moment in lunar exploration. It promptly transmitted its first image of the lunar far side area and deployed its rover named Pragyan, which means wisdom in Sanskrit. Within an hour of landing, the lander and rover embarked on their scientific mission on the moon. Chandrayaan 3 is equipped with two primary objectives: to showcase India's capability for soft lunar landing and roving, and to conduct a range of scientific experiments to investigate the lunar environment and available resources. To fulfill these objectives, Chandrayaan 3 carries 14 carefully selected payloads on both the lander and the rover designed to measure various aspects of the lunar surface and subsurface. These measurements encompass temperature, radiation, seismic activity, mineralogy, and chemistry. Among the crucial payloads on the lander is Chastity, Chandra's surface thermophysical experiment, featuring a rod-like probe capable of penetrating up to 10 centimeters into the lunar soil to measure temperature profiles at various depths. This pioneering experiment is particularly significant in the South Pole region, where temperature fluctuations can range from -10 to 60 degrees Celsius depending upon the depth. The data collected by Chastity will aid in estimating the depth at which water ice is buried under the lunar soil, providing valuable insights for the future lunar exploration and resource utilization. Another pivotal payload on the lander is the Lunar Reflector Array (LRA), comprising 8 mirrors that can reflect laser beams from Earth or other spacecraft. This technology facilitates high-pressure distance measurements between Earth and the Moon and allows for test of Einstein's theory of general relativity. Furthermore, the LRA can detect low-frequency radio signals from the far side of the Moon, potentially revealing clues about its origin and evolution. The rover Pragyan also carries significant payloads, including the alpha particle X-ray spectrometer, which can analyze the chemical composition of the lunar rocks and soil by bombarding them with alpha particles and X-rays. This data enables identification of minerals and elements on the lunar surface, aiding in the understanding of their distribution and formation. Another noteworthy payload on the rover is Laser-Induced Breakdown Spectroscopy, a device that vaporizes a small quantity of lunar material using a powerful laser beam and subsequently analyzes its spectrum. LIBS helps determine the abundance and isotopic ratios of various elements on the lunar surface, facilitating comparisons with Earth's composition. These examples illustrate the wealth of scientific information Chandrayaan 3 aims to gather during its mission, shedding light on the lunar South Pole's unique environment and potential resources, and contributing to our understanding of Earth's nearest celestial neighbor.